All right, problem 17, we have that we want to obtain certifications for a certain occupation. Candidates take a proficiency exam. The exam consists of 2 sections, and neither section should be more difficult than the other. To investigate whether one section of the exam was more difficult than the other, a random sample of 50 candidates was selected, and the candidates took the exam and their scores in each section were recorded. The table shows the summary statistics. All right, so it looks like they recorded the mean score in each section and then found the difference, where the first section mean minus second section mean. Which of the following is a test statistic for the appropriate test to determine if there is a significant mean difference between the percent correct on the 2 sections, first minus second, for all candidates similar to those in the investigation? Okay, so we're looking, again, at a test to determine if there is a significant difference between means. So if you remember this acronym, ZAPTAX, this helps you remember that when you're doing a test dealing with proportions, you're going to use a z-test. When you're doing a test dealing with sample means, you're going to do a t-test. So we know it's going to be some sort of a t-test. So it's not going to be E, and it's not going to be C or D, because these are chi-squared tests, and this is when you have categorical variables, and here we have quantitative variables. We have these values of mean. So the key is to figure out whether it's A or B. Now, what's the main difference between A or B? Well, in A, we basically are doing a t-test when we just have one sample. So if you look at your multiple, or you look at your formula sheet, you can kind of get a hint. Let me erase that so you don't get confused. But when you have a single sample, you're going to have a standard deviation of the statistic in this form. When you have a 2 sample, your standard deviation of the statistic will be like this. Difference of sample means, and this is just a sample mean. So this is going to be 2 samples. This will be 1 sample. Now, this is just 1 sample because all you're talking about is the 50 candidates. Even though you're recording 2 values on each candidate, it's not 2 samples. It would be 2 samples if you had 50 candidates that took only the first section and you had another 50 candidates that took the second section. But this is kind of like both taking the same one, or both taking both, because you're only recording this in your data. You're basically using these differences as the value that you're going to run in your t-test. So it's just going to be A. All right, look at number 18. Okay, so new employees at a large corporation go through a training program during their first week of employment. The new employees take a written assessment at the completion of the program to determine how well prepared they are for their jobs. A score greater than the mean indicates a well-prepared employee. Assume the following distributions of new employees' scores have the same mean score, the same maximum score, and the same minimum score. That's interesting. Which distribution has a shape that is most likely to represent the greatest percent of well-prepared employees? Okay, so this is kind of like a logic problem. Essentially, you want to basically have the employee scores be, on average, be greater than the mean population score. So let's say you have like the mean population score is like this here. This right here is going to lie where the mean population score is. Now, if you want to basically have the greatest percent of well-prepared employees, their mean score has to be bigger than this one. So their mean score is going to be somewhere to the right. Let's call that, X bar, sample mean of that. And that would mean that you would have your density, or the majority of your data centered around here, but not really centered, because again, this is a true population mean. So you would actually have like a skewed distribution, skewed to the left. And again, this is kind of more logical than really like a calculation. If you want to look more into this, this would be basically dealing with stuff and distributions you actually learn properties of distributions in like chapter 1, where you talk about sensitivity, to outliers and, types of shapes. But it would just be simply B. It would just be B. All right, number 19. Got, based on his past record, Luke, an archer for a college archery team, has probability 0.9 of hitting the inner ring of the target with a shot of the arrow. Assume that in one practice, Luke will attempt 5 shots of the arrow, and each shot is independent from the others. Let the random variable x represent the number of times he hits the inner ring of the target in 5 attempts. The probability distribution of x is given in the table. So here are the possible x values, and here are their corresponding probabilities. What's the probability that the number of times Luke will hit the inner ring of the target out of 5 attempts is less than the mean of x? So what's the probability that Luke will have an x value less than, let's say less than the mean of x? We have to find what the mean of x is. So we just have to do a calculation, knowing that this is a independent random variable. And again, let me crank out my formula, our formula packet. Because all you're basically going to be looking at is this equation. The expected value of x to mu sub x. Remember this when you learn about random variables. And that would just be the weighted average. So the mean of x, you take, remember, you take the corresponding value multiplied by its probability and add them all up. So we would have 0 times 0.001 plus 1 times this, plus 2 times that, plus 3 times this, plus 4 times that, plus 5 times that. So it would look like, 0 times the probability that x is 0 plus 1 times the probability that x is 0.0, probability that x is 1. So forth. Anyways, let's just use our calculator to save our tedious work. So 0 times that, that's just 0, so we don't gotta enter that. 1 times that, 0.00045, plus 2 times 0.000, whoops, 0.00810. What is going on with my calculator? Point plus 3 times that, 0.07290, plus 4 times 0.32805, plus 5 times 0.59049. And we'll get 4.5. So essentially, we want to find the probability that Luke will hit the inner ring of the target less than 4.5 times in 5 attempts. Now, this means that he can hit it either 0 times, 1, 2, 3, or 4. So since 4.5 is not, actually a value that he can get, we just basically have to add up the probability of, getting either 0, 1, 2, 3, or 4. And since they're independent, you just add those values up. Or you could just do 1 minus this value, same thing, because they all have to add to 1. So I'd rather do that. So 1 minus the probability that x equals 5, or 1 minus 0.59049. And this will just be about 0.4. So out of calculator, say about 0.4, which will be A. So our answer